Okay, let's go ahead and get started again. So I'm going to launch into talking about submitting jobs and how you go about doing that and how you know basically what accounts you can submit under and how you would submit different kinds of jobs that are running in serial or in parallel, those sorts of things. So the first thing to know is Christopher mentioned this idea that there are different partitions. And so you may or may not have access to a particular partition, which is a particular group of nodes that all have the same hardware, without running the command that I'm about to show you. So this is quite a useful command. So this saccount manager show associations. And so what you would do is you would do that, and then you would enter user equals and then your username. So I'm going to enter my username. This is going to produce rather more voluminous output than you would get because I have access to a number of different accounts because of the particular position I have. But the key things that we can see here are if you have access to a faculty computing allowance, you're going to see some lines that look like this. And basically what this shows it's a little bit hard to read here, but in the fourth column here, separated by these pipes, what you'll see is that with the faculty computing allowance, you have access to, for example, GPU nodes. You have access to the HTC partition, which I'll talk about a little bit later. You have access to the big memory nodes on Savio 2, and you have access to Savio 2 and the Savio 2 and Savio partitions. So under a faculty computing allowance, you would have access to all of those at a normal priority. So that means you can submit jobs and you'll be sort of in the queue with everybody else to get access to those jobs. And the fact that you have normal access is indicated by this Savio _ normal over here in one of these more right-hand columns. If you have access to a condo, that means that you, or if you're a PI, you or the PI that you're working with has actually purchased nodes on Savio, and that's what Christopher was describing before. So in this case, I have access to a particular condo that's basically run through the statistics department. And so I see that down here in some of these additional lines that are produced as output from this saccount manager command. So what I see down here is these are all the partitions that I have access to through my condo association because I'm associated with a condo. But you'll notice for a lot of these, many of these have Savio _ low priority associated with, listed here. And what that means is I don't have regular normal prior access to those because I didn't purchase any of those kinds of nodes, or we didn't purchase any of those kinds of nodes. The ones that I have regular access to are the ones that have a normal, so this stat GPU 2 normal and the stat Savio 2 normal. So those are the two partitions, Savio 2 GPU and Savio 2, which I have access to as part of my condo because we purchase nodes that are in the Savio 2 and Savio 2 GPU partitions. So in general, if I were using the condo, I would want to use one of those two partitions because those are partitions where I have sort of access that's guaranteed by the purchase that we've made. You can also run jobs at a low priority setting, and those jobs are subject to being canceled if other people who have higher priority come on and want to use those nodes. I'll talk about that a little bit more in a few slides. But that's the basic distinction that you would be looking at, is whether you're in an FCA, which means you have regular access to all kinds of nodes, or most kinds of nodes, there are a few exceptions, or if you have a condo, which means you have high priority access to the kinds of node that you bought, and lower priority access to the things that you didn't buy. Okay, so any questions on that front? Okay, actually, I guess I got ahead of myself because that was actually the next slide. So let me give a little bit of an overview on submitting jobs. It doesn't really matter which order I went in. So basically, when Christopher already said this, when you submit a job, the basic sort of workflow for working on Savio is you'll log into the login node. Christopher already demonstrated that. And then you will change directories to wherever you have a job script that you want to run. And we'll talk about job scripts in a minute. And once you've changed directory to where you have a job script written, you can then submit that job script as a job to the scheduler. And what will happen is that if we go back to the schematic that Christopher showed, so here you are, you're on a login node, you've changed directory to the directory you want to be in, you then submit the job to the scheduler, to Slurm, and Slurm will then put your job on one or more of these nodes, depending on how many nodes you've requested. So the job will be running on one of the compute nodes rather than running on the login node, but you've submitted the job from the login node. And in general, when you submit the job, the current working directory of where the stuff in the job, where the code in the job will run, is the directory from which you submitted the job. Now you can change directories in your script if you want to, but by default that's the directory that it will be running from. So that's the basic workflow. If you find yourself doing something where you're starting to run some computations without using either the sbatch or the srun commands, it means you're doing something wrong because you're going to be running your code on the login node. And that's really we really only allow you to do that if you are just running, if you're doing a compilation or if you're moving files around, and a shorter compilation. If you ran a compilation that takes like an hour, we'd want you to do that on the compute nodes as well. Or if you just want to do something really quick, you want to start up Python and just like check if you can run a few functions or something like that. That would be okay to do on the login node. But if you end up running a computation for more than like 5 minutes, and if you're going to use more than one CPU, that's the sort of thing you should be doing via Slurm on the compute nodes. Okay, so I already discussed this idea of figuring out what partitions you have access to. Okay, so the next thing is to give you a sense of what does it look like to actually submit a job to Slurm. So what you would be doing is you would be writing a shell script that basically is just a text file that looks something like this. And this is a little bit of a funny script because it has all these comments up here with the hash marks. Some of these comments are really instructions to Slurm on how to submit your job. And then the things that don't have comments are the actual code that you want to run, which is the actual computation you want to do. So in this case, you'll always have hash bang bin bash up here that says that this is a bash shell script. And then any place where you see the hash mark and then the capital word sbatch, that's an instruction to the scheduler of how to go about running your job. So the sorts of things that you would put in here is you can optionally name the job so that when you sort of query the different jobs that are running, you see the name of it. You would generally need to say what account you want to run under. So in this particular case, I'm running under this condo that I just mentioned. If you have an FCA, you would be writing something here like FC underscore in the name of your FCA. And then you'd be saying what partition you want to run in. So for example, I could run in the Savio 2 partition. And then oftentimes you would be saying how many cores and how many nodes do you want to use for your job. And we'll see that in a little bit. By default, if you don't say anything, you're going to get access to a whole node on almost all of the partitions except for one that I'll mention a little bit later. And then the other thing that you're required to put down is a time limit. If you're on a condo, then the time limit will depend on the condo. But for most users, the maximum time that a job will run is for 3 days. So you could put 3 days on here. If you know it's going to run rather shorter than that, you should put a more realistic time limit. And the advantage of that for you is that may mean your job will start running more quickly because the scheduler is trying to juggle different jobs. And if it's a short job, it may be able to sort of fit it in amongst all the other jobs that are running. And the advantage for us is that the Slurm scheduler can better manage all of your competing jobs if it has a realistic estimate of how long the job will take. Now, it's a bit of a catch-22 because sometimes things happen that you're not expecting and a job takes longer than you expect. So you're like, oh, I think this will take an hour, and you find out it takes an hour and 5 minutes. That means the job's going to get killed after an hour, and you'll lose all that work unless you've saved output temporarily in some fashion. So you can be on the generous side in terms of putting down the time limit. If you think it's going to take 3 hours, you might put down a time limit of 6 hours just to be on the safe side.
But I have a question. So if it finished before, it doesn't count on your time?
No, you're charged for the amount of time the job is running, not the. I'm pretty sure you're charged for the amount of time the job is running, not the amount of time that you requested. Yeah. Okay, so these sbatch commands are the things that say how the job should run. And then down here is basically just the code that you want to run. So this could be invoking Python or MATLAB. It could be invoking some bioinformatics tool that you're going to use. It could be invoking MPI run if you're running a job across multiple nodes and you need to use MPI if you know what that is. Here, all I'm going to do is I'm just going to run a very basic Python script. So I'm going to load the Python 3.6 module. So Christopher talked about loading modules. And then I'm going to run Python and just run the Python code that's in this calc.py function. And I'm going to redirect the output and any error messages to a file calc.out. Okay. So let's just do a demo of this and see what this looks like. OK, so I should have, if I look at this job.sh file, that should be essentially the same as what I just showed you in the slides. Okay. And if I look at calc.py, That is really just some Python code. I'm a statistician, so a lot of what we do is linear algebra. So all I'm doing is I'm just doing some linear algebra here that happens to be fairly intensive linear algebra calculations. It doesn't really matter what it is for the sake of this demo. So in order to submit this job, all I need to do is run sbatch and then the name of the job script that I just showed you there. Okay. And you could create the job script on your laptop and then copy it over in the way that Christopher was talking about, or you could create and edit the job script on Savio itself using Vim or Emacs or Nano, the tools that he just mentioned. Okay, so I'm going to do sbatch of job.sh. And you'll see that it reports back the ID of the job. And this is going to be useful potentially in the future for sort of querying the system and seeing what the status of your job is. And so some of the things we can do in terms of looking at the status of our jobs is we can do sq-j. And that will show us some information. We can do wwal-j and then the job ID. So let's go ahead and do that. I could, for example, do sq-j 5034688. And that will show you that that job is pending. And the reason that it's pending is because there aren't any nodes available to run the job. I'm now basically in a queue of jobs that would be run in a certain order. So I'm going to cancel this. I'm going to do scancel and then again the number of the job. And for the purpose of this training, we set up what's called a reservation that basically reserved 2 nodes for my use to do the presentation. So we're going to do ---- reservation equals Savio 3-training. So you wouldn't usually do this reservation thing. That's just for the purpose of getting access to the nodes on an expedited basis here. OK, and then I would still need to do the job.sh. Oops, I need to do sbatch here. OK, so I'm just resubmitting this job under the reservation. And now I got a new job ID. You can see it incremented a little bit relative to the old one. It incremented by 4, which means that there were a few jobs in the interim that somebody else submitted that got the IDs in between. So now I can do sq-j 5034692. And now it shows that that's pending, which is a little bit odd because I have this reservation set up. I'm actually not sure why it's doing that.
Can you give an estimation of how long you're going to wait for the job to start?
What's that?
Is it possible to have an estimation?
There is a command, I think, to do that, and I'm forgetting what it is off the top of my head. Yeah.
Your reservation was at Savio 3. Why did the job go to Savio 2?
Ah, that is the problem. Thank you. It's always good to have extra eyes on the task here. So I'm going to go in and edit this file and change it to Savio 3. So most people don't have access to Savio 3, and I generally don't use Savio 3, which is why the demonstration was for Savio 2. And then it turns out that in order to set up the reservation, it made sense to do it on Savio 3. OK, so let me cancel that again. And let's submit this again. OK. Let's see. OK, so it may be that it doesn't like this account for this. Yeah, it's probably that. So this is a special account that I have access to because I work for the program. OK, so hopefully this will now work. OK, so now we can do the sq command and see what happens with it. So that was now 5034695. OK, so that is now running. And we can see that because of the capital R here, whereas before we saw the PD, and that was for pending. Okay. And it's been running for 8 seconds. And I can do things like wwal-j, and again, this 5034695. Not sure why that happened. Yeah. Okay, so I think that would usually work. I'm not quite sure what is. So did I get the job ID? 5034695. Yeah. Okay. All right. So I'm not quite sure why that's not working. That should, in general, work. I can also do things like sq-u and then my username. And this should show all of the jobs that I have. Oh, I see. OK. this should show all the jobs that I have that are running. At the moment, there's nothing running, and that explains why wall didn't produce anything, because in the time that I was monkeying around trying to type in the commands, the job started and finished, and there was no job running. So this warning is not very helpful, and obviously it didn't clue me into what was going on, but no node selected is an indication that the job wasn't actually using any nodes because it wasn't actually running. So let's see if that job actually produced any output. So this calc.out was the output file that I created, and if I look at that, we can see that it produced whatever numerical output I asked it to produce. So it did actually run. For the sake of illustration, I'm going to run the job again. And this time, I'm going to hopefully do wall quickly enough that we can see what it shows. OK, so you can see that it's basically showing the total CPU utilization here and also the amount of memory being used. And so if the Savio 3 nodes, it looks like, have about 96 gigabytes of memory, and that's what's being shown here. And my job is only using about 3 gigabytes, so it's not really using very much memory, which is good. If you start to see this getting up to like 80 gigabytes or 85 or 90 gigabytes, that would be an indication that your job might run out of memory and it might get killed because it ran out of memory. So this is a good way to monitor that. The other thing that's quite useful here is monitoring the percentage of usage here. If you are running a Savio job on almost all of the partitions except for the HTC partition that I'll mention briefly in a little bit, you get access to the entire node and you are charged for the entire node. And so what that means is you, in general, don't want to be running a job where you're only using one core on the entire node because you're basically wasting all of the other cores. If you need to do it, you can do it, but you would be charged for it. And so this is an indication that I'm only using one of the cores, one of the CPUs on this particular node, because 3% of 32 cores is basically one core, 1 out of 32. And so ideally, what you would see here is 100% or a high number near 100%. So this is an indication that my code was really only running basically serially. It wasn't using any parallelization. And I'll talk in a little bit about some strategies for how you could try and make use of all of the cores on a node. OK, so any questions? Yeah.
Is there a version of wall where you can monitor these numbers in percentages in time?
Oh, over time?
Over time. They change.
There is a command that we'll see in a second that will tell you after the job has run what the result is. You can do things like the watch command in Unix. If you did like watch -n1 wall -j 5034700. This job is now finished, I think, but watch basically just refresh the output, and you can just see it sort of doing it in real time. Other questions? Okay. All right, so let me go back to the slides, partly just to remind myself of where I am. Yes?
Is there any command to list the running jobs?
To list the running jobs, yes. So that's the SQ command would show all of your jobs either pending or running. So I would do -u Pechoric to see mine. Or if I want to see all of them, I can just type SQ, and that will now list out all of the various jobs that are running and pending on Savio. So this would be a way to get a sense of what's running and how much is running. OK, other questions? There are a few other things that you can do here in terms of looking at the stat at how much resources were used on a job that has already finished, and you can actually log into the node into a node that you're running a job on and run top to be able to sort of see what's happening on the node. So there are some commands for that here that I won't go through in detail. OK, let me say a little bit briefly about parallel job submission. So in addition to specifying the time limit and the account and the number of nodes, and the partition that you want to run on, you can also specify basically the amount of what kind of resources you want. And what I mean by that is basically how many nodes and how many cores you want to use for your job. So if you want to use more than one node and do parallelization across more than one node, you can specify the --nodes flag, and you would put this in the same kind of style as you do here. You'd have an S-batch line where you put --nodes, for example. You can also say how many processes you want to run per node. This would often be used if you were using MPI, and basically there the number of MPI processes corresponds to this word of tasks here. And you can also say how many CPUs you want to use per task. So depending on exactly what you're doing, the notion of what a task is may change. But what's going to happen when you do this is going to determine basically how many nodes Slurm assigns to you. And it will also result in setting some environment variables inside your job that can then be used to basically understand that your code or other code that other people have written can use to understand how many cores are available and how many nodes are available. So that will all be set based on having passed these flags in here. So here's an example of that if you were running a job that uses MPI. So one of the main ways that you would use multiple nodes on Savio is if you're either writing your own MPI code or you're using some software where somebody else has set up that software to use MPI. And MPI is a protocol for basically passing information and data from one node to another. So if you're going to do if you're going to parallelize across multiple nodes, you need to get information between the nodes, and MPI is the way that you do that. So here's a little bit of an expanded job script. So this is just like that job.sh file that I showed you before, except now it's basically set up to run some MPI code in parallel. And so I've added this flag here, --n tasks equals 40. And this is on, I think this would naturally be done on Savio 1 because Savio 1 has 20 cores per node. So this would naturally amount to having 20 cores per node on 2 separate nodes for a total of 40 processes or cores. And so if you set this up this way, when you then load in OpenMPI and you run a job via MPI, MPI will actually communicate with Slurm and will realize that you have asked for 40 tasks. And what that means is it will start up 40 processes to do the parallelization, and MPI will then be managing the communication between those 40 processes. So if you're not familiar with MPI and that didn't mean much to you, that's okay. But for those of you who know something about MPI, hopefully that was helpful. Yes?
Is that one per core?
What's that?
That's one per core.
Yeah, you don't really need to set the CPUs per task in this case. The default is actually 1. And there are ways that you could combine MPI with also using threading, so you could have tasks that use more than 1 core. But in general, you only want to use, in general, you don't want to overload your cores. You want to basically have each core running at 100% of CPU. And so either you'd want to have 1 CPU per task and as many tasks as you have cores, or you'd want to have fewer tasks than cores and have multiple cores per task. So there's some arithmetic you can sort of work out to think about that. And so the sort of common sort of things that you might end up with is sort of what I just said, an MPI job with 1 CPU per MPI task, an OpenMP or a threaded job on 1 node where you have multiple CPUs for 1 task, or you could do a sort of a hybrid sort of thing. And there's lots of variations on this. We have some guidance here in this link on submitting jobs in these different flavors. And we're happy to take questions on sort of this sort of thing of like, what's the best way to sort of set up parallelization with some particular software that I'm using? But one thing to keep in mind is, in general, it doesn't make sense to ask for more than 1 node unless you know that the software you're running is capable of being run on multiple nodes. Some software is, but lots of software is not.